For this video, we want to factor the polynomial that we're given using the greatest common factor, or GCF method. And so our polynomial is 3x squared plus 6x. And so what we want to do is we want to look at the 3x squared and we want to look at the 6x. We want to figure out what the greatest common factor is that we could factor or divide away from both of those terms. So for a problem that involves numbers and variables, I would advise looking at the numbers first and seeing what the greatest common factor of the two numbers are, and then look at the variables and figure out what the greatest common factor of the two variables are. So for this case, we have a 3 and a 6, and so the greatest common factor of 3 and 6 is 3. And then looking at our variables, we have an x squared and an x. So the greatest common factor of x squared and x is going to be x. And so our greatest common overall factor is going to be 3x. And so now what you want to do is you want to open a set of parentheses, and then you want to say to yourself, if we divide 3x away from 3x squared, what's left over? Because when we're factoring, we're dividing it or pulling it out front. The only thing left over in this case is going to be an x. And you can kind of check this in your mind. You can go back and mentally say 3x times x. Okay, yes, that equals 3x squared. So you're on the right track. So now we're going to bring down the plus sign from between the 3x squared and the 6x. And so now again, ask yourself, if we divide away or if we factor out a 3x from 6x, what is left over? All that would be left over, it would be a 2 if you divided that. And again, you can kind of mentally check yourself by multiplying or distributing the 3x back to the 2 and making sure it equals the 6x that you started with. And so now after factoring out the greatest common factor, we have 3x multiplied by x plus 2, and that's going to be our final answer. Again, you can always check yourself with factoring by multiplying or foiling it back out and making sure that it matches the original problem.